Dear students, in this session we will discuss the third motive for demanding money, namely the speculative motive. The speculative motive for holding money. Now, the proposition that money is held for transaction purposes and also for precautionary purposes will not conflict with the classical view. Whereas speculative demand for money is actually a break with the classical view. According to classical economics, a person will not hold money in excess of what is required for transaction purposes. A person will not hold money in excess of what is required for transaction purposes. Holding money in excess of what is required for transaction purposes means he is sacrificing interest by not investing this excess money in an interest-bearing security, bond, etc. So a person will hold money only as much as required for transaction purposes. But in the 1930s, that is during the Great Depression of 1930s, Keynes observed that people hold money in excess of what is required for transaction purposes. And it is from this observation that Keynes introduced his speculative demand for money. And Keynes pointed out that a person who is buying a bond, is speculating that interest rate will not rise appreciably during the period in which he is intending to hold this bond. Or stated differently, a person who is purchasing bonds believes that interest rate will decrease in future so that the price of bond will increase and he will get a capital gain. And if he believes that interest rate will increase in future, he will not purchase bonds, he will keep non-interest bearing money. That is, he will keep his wealth in the form of money rather than bonds. So a person's plan to purchase a bond depends on his assumption, expectation about future movement of interest rates. If a person believes that interest rates will rise in future, he will hold money. If he believes that interest rate will fall in future, he will purchase bonds. So this uncertainty as to future interest rate causes people to hold money for speculative purposes. That is, uncertainty about future interest rate causes people to hold money for speculative purposes. So, in order to understand speculative demand for money, we must examine the relationship between one, the market rate of interest R, market rate of interest and the maturity price of a debt security like a bond. Consider a US government bond. We examine the relationship between market rate of interest and maturity price of a debt security like US government bond. A bond has no credit risk. A bond has no credit risk. A bond has no credit risk means there is no risk of default. On maturity, government will redeem the bond, repay the sum given in the face value. So, there is no default risk. Also, there is no marketability risk. There is no marketability risk. Marketability risk means there is no liquidity risk. If you buy a bond having say 10 years maturity and if you wish to sell the bond after 5 years, there is always a market for this bond. There will always be someone to purchase this bond. So, there is no marketability risk. But a bond is subject to what is known as market risk. A bond is subject to what is known as market risk. Market risk is the risk that market rate of interest may change. Market rate of interest may change. Now, the US government bond is a debt instrument and like any other debt instrument is freely traded in the market. In India, government issue bonds, short-term government bonds known as treasury bills, long-term bonds are also issued by the government for raising money, and the sale and purchase of this bond take place in the secondary market, namely the stock market. So, the case is with the US government bond freely traded in the market. It has a dollar amount that is the face value. As I told you in the last class, say $1,000, a face value, and also an interest rate known as coupon rates. If a bond with a maturity of 5 years or 10 years offers a coupon payment of $100 per year, then coupon rate is 100 by 1000 equal to 10%. And the coupon rate multiplied by the face amount is the amount received yearly by the buyer of the bond. For example, 1000 into 0.1 is equal to 100. That is the coupon payment obtained by multiplying coupon rate with the face value. Now, let us consider a concrete example. It is a repetition of what we have discussed in the previous class. Anyway, suppose that a bond has 25 years of maturity maturity. Face value is $1,000 and also assume that coupon rate is 5%, 0.05 or 5%. Also issued in 1965. Suppose that this is a bond issued in 1965, maturity is 25 years. Then face value is 1,000, coupon rate is 5%. Now the question is, and the US Treasury ensures $50 from 1966 to 1990, and on maturity the Treasury will repay $1,000 also. Now suppose that this is year 1985. This is year 1985, 20 years after issuing the bonds. Now the question is, what will be the price of bonds in 1985? What will be the price of bonds in 1985? In other words, what will be the present market value of the stream of income from 1985 to 1990, that is $50 per year, from 1986 to 1990, what will be the present value of the stream of interest income from 1986 to 1990, and a principal equal to 1,000 received after 5 years. This is, if you buy this bond in 1985, you will get a 50 per year for the next 5 years and 1,000. The question is, what is the present value of this future stream of income, and that will be the price of bonds in 1985. So to develop an equation for this present value of future streams, we use what is known as the ordinary compound interest formula, which we have developed in the context of the theory of investment. We repeat it once more. Suppose that market rate of interest ROI, whatever it is 5%. Rate of interest is 5%. If you give a 95.24 at 5%, $95.24 at 5%, after 5 years it becomes $100. After 5 years, this amount becomes $100. That is, I write it as P1 is equal to PC into 1 plus R. That is equal to 95.24 into 1 plus 0.0 is equal to 100. P1 is equal to P0 into 1 plus R. If you give a P1 amount for a second year, what is P2? P1 into 1 plus R is equal to P0 into 1 plus R square. P2 is equal to P0 into 1 plus R square. If you give a P1 for a second year, or P0 for 2 years, P2 is equal to P0 into 1 plus R square, and in general Pt is equal to P0 into 1 plus R raised to T. Pt is equal to P0 into 1 plus R raised to T. So this is the future values, that is Pt of an amount P0 is equal to P0 into 1 plus R raised to T. To find out the present value, we reverse the process of accumulation. Compounding is replaced by discounting. Present value of 100 receivable after 1 year at a rate of interest equal to 5% is P0 is equal to P1 by 1 plus R, or dividing both sides with 1 plus R, you have P1 by 1 plus R is equal to P0. That is equal to 100 by 1 plus 0.05. That is 95.24. 95.24. After 2 years, this can be written as P0 is equal to P2 by 1 plus R square. From this, dividing both sides with 1 plus R square, P0 is equal to P2 by 1 plus R square, and after t years, Pt is equal to P0 is equal to Pt by 1 plus R raised to t. So to find out the present value of a future stream of income, we discount this. If after 1 year with 1 plus R, 2 years 1 plus R square, t years 1 plus R raised to t. Now, if we can find the present value of series of future sums generated by any bond, this is for one future income, but a bond will generate future series of future incomes, and we can calculate the present value of this series of future incomes by using this present value criterion. Let us see how. Suppose that PV is present value, R1, R2, etc. Rn. R1, R2, etc. Rn are the streams of interest income. A is face value. Then PV is equal to R1 by 1 plus R plus R2 by 1 plus R square plus Rn by 1 plus R raised to n plus A by 1 plus R raised to n. That is, present value is equal to the discounted amount for the year 1, year 2, year n, and also the discounted amount on maturity. So, R1 by 1 plus R, R2 by 1 plus R square plus etc. Rn by 1 plus R raised to n plus A by 1 plus R raised to n. Now, consider this bond. The bond is issued in 1965, mature in 1990, and today is 1985. So the question is, what will be the present value of this bond? The bond was purchased with $1,000 and a face value of 5%. Then, for this bond, present value is equal to 50 by 1 plus. Now, in order to calculate the present value of this bond, we have to consider the current market rate of interest. Suppose that the current rate is 8%, that is 0.08. Current interest rate is 8%, 0.08. Then present value is equal to 50 by 1 plus 0.8, 50 by 1 plus 0.8 square, etc. 50 by 1 plus 0.85 raised to 5 plus 1000 by 1 plus 0.08 raised to 5. That will give you a value equal to 880.21. You purchased the bonds for 1000, and if you try to sell the bond in 1985, you will get 880 only, because the current rate of interest is 0.08. At the time of purchase, it was 0.05. And we will say that the bond sells at a 12% discount from the face value. If the current rate of interest is 4%, 0.04, then if you substitute the values here, it will be greater than 1000. And we will say that the bond is sold at a premium. If the rate of interest increases, bond is sold at a discount, whereas if it is sold at a price greater than the purchase price, we say that the bond is sold at a premium. Now this calculation is simple if we consider what is known as a perpetuity. If we consider a perpetuity, this calculation is simple. An example is console, which we have discussed in the previous class, issued by the British government. What is peculiar about perpetuity or console is it has no maturity value. Government will give a fixed sum every year. If you want to sell the bond after some years, you can simply sell it in the secondary market. And in the case of a console, PV is equal to R by R, as we have discussed in the previous class, R by R. And suppose that for the console you paid $1,000, offering a 5% interest rate, then the present value is 1000 with R is 50 by 0.05 is equal to 1000. And if the face value is 1000, offering 50 per year, present value is 50 by 0.05. So that you have R is equal to 50 by 1000 is equal to 0.05. Now this is the bond, its purchase price, return, etc. Now the question is, what is the worth of the bond today? It depends on the current interest rates. Suppose that in the year 1985, interest rate is same as 5%. Then in 1985 also, the price of the bond will be 1000. On the other hand, in 1985, if R increases to 10%, price of bond become 500. Price of bond become 500. So that 50 by 0.1 is equal to 10%. So if the rate of interest increases, you have a capital loss on the bond you have purchased. What I say here is, in the year 1985, coupon payment was 50, so the rate of interest is only 5%. In the year 1985, coupon payment is 100. And for your bonds, you will get only 50. So you have to equalize the price the return on all the bonds. Someone will purchase your bond in 1985 if and only if you offer the bond for 500. So, what I say is a rise in the market rate of interest results in a capital loss on previously existing bonds, or there is an inverse relationship between current rate of interest and the price of previously issued bonds. If on the other hand, if the market rate of interest decreases to 2%, price of bond become 2,500. So a decline in interest rate results in a capital gain on previously existing bonds. So remember this, a bond is purchased in a certain year. If the market rate of interest increases, you have capital loss. If market rate of interest decreases, you have capital gain. So whether you will purchase a bond or whether you will keep your wealth in the form of money depends on your expectations about future interest rate. That is, whether future interest rate will increase or decrease. That we will consider in the next class.